Welcome to my presentation. This presentation is part of the playlist Integral of Logarithmic Functions. Let us look at some example problems related to this particular logarithmic functions. Let us say if we want to evaluate a function as shown here, integral 6x divided by x squared plus 1 dx, we're going to use the substitution method in here. So let us substitute u as equal to x squared plus 1. X squared plus 1 is in the denominator. U is a function of x. As we can see here, u is a function of x. We're going to differentiate u with respect to x. Du by dx is equal to 2x. d by dx of x squared is 2x to the power of 2 minus 1, which translates to 2x, and d by dx of 1 is 0. So 2x plus 0 is equal to 2x. So therefore I just left 2x here and did not mention 0 there. So we can express this as du as equal to 2x times dx. So we brought this dx to the side of the expression of 2x here. If we want to express this in terms of dx, we can write it as dx is equal to 1 over 2x du. Now we can substitute u as equal to x squared plus 1 and then dx as equal to 1 over 2x du, like that. Now we're going to substitute u and dx into our given example problem and then use the rules of integration and then solve this example problem. So our example problem is 6x divided by x squared plus 1, and wherever we see x squared plus 1, we're going to substitute that by u. As you can see here, 6x divided by u, and then wherever we see dx, we're going to write 1 over 2x du, like that. Okay. Now as we can see here, we have a 6x in the numerator, 2x in the denominator. Excuse me. So the x and x cancels out. 6 is the multiples of 2, and then when we simplify, it becomes 3. And since 3 is a constant, I've written it outside of the integration process. So we are left with 3 integral 1 over u du. So when we take out when we simplify all of this expression here, it simplifies to 1 over u du. So we know the rule is stating that integral 1 over u du translates to ln of u, like that. So we can write this as 3 ln of u plus c. So since u we started to say as x squared plus 1, so we're going to substitute wherever we see u as equal to x squared plus 1. We want to be able to express our final answer in terms of x and not in terms of u. So therefore, wherever we see u, we're going to replace it by x squared plus 1. So we can rewrite this as 3 in ln of x squared plus 1 plus c, like that, where c is a constant of integration. So this is the way we want to solve example problems which involve logarithmic functions. So let us look at another example. Let us say we want to evaluate this function integral x squared divided by x cubed plus 1 dx. We are going to use the logarithmic rule to solve this example problem. Okay, let us substitute u as equal to x cubed plus 1. X cubed plus 1 is in the denominator of the example problem. So u is a function of x. So since u is a function of x, we can differentiate u with respect to x. Du by dx is equal to 3x squared. So how is that? D by dx of x cubed is going to be equal to 3x to the power of 3 minus 1, which equals to 3x squared. And then d by dx of 1 is going to be equal to 0. So I did not write that. So therefore, the differential of u is going to be equal to 3x squared. And then I can also express this as du as equal to 3x squared dx. So I brought the dx to the side of the expression here. If I want to express this in terms of dx, I can write it as dx is equal to 1 over 3x squared du, like that. Now we can substitute u as equal to x cubed plus 1 and then dx as equal to 1 over 3x squared du into the given example problem, and then use the rules of integration and then solve this example problem. Okay, so our example problem is x squared divided by x cubed plus 1 dx. So therefore here, wherever we see x cubed plus 1, we're going to replace that by u, as you can see here. The numerator part we have x squared, in the denominator part we have substituted that by u, and then wherever we see dx, dx, we're going to replace that by 1 over 3x squared du, like that. Okay, so now as we can see here, we have an x squared in the numerator, we have an x squared in the denominator, those terms cancel out. We have a 1 over 3, which is a constant. We can pull that outside of the integration process, and then we can write it as 1 over 3 integral 1 over u du. When we simplify all of this, what we are left with inside the integral term is 1 over u du. So we know the rule that integral 1 over u du translates to ln of u. So we can write this as 1 over 3 ln of u plus c, where c is a constant of integration. As we mentioned, that we cannot leave our answer in terms of u. We need to write it in terms of x. So wherever we see u, we're going to replace that by x cubed plus 1. Therefore, we can write this as 1 over 3 ln of x cubed plus 1 plus c, where c is a constant of integration. So this is the way we're going to solve example problems involving logarithmic functions. In my next video presentation, we will solve more examples related to logarithmic functions.